Okay, so today, no matter what, we want to make sure that we write over here radian. Okay, what is a radian? A radian is an angle. Okay, a radian is an angle. Write that down. A radian is an angle where it is also equal to its arc length. And that's what makes radian so special, is because you have an angle, it's also equal to its arc length. There's a definite connection. We saw that when we started working on the unit circle, okay? So if that's the case, a radian is an angle where it is also equal to its arc length. If that's the case, then if I go back to page 229, and here they have the circle, okay? And they put down all of the angles in degrees, and they put down the angles in radians. We know that the arc length here, this actual arc length here, is pi 6. And Cooper said that was about 0.52 blah blah, right? So any of these arc lengths are always going to equal these radian measures if the radius is 1. Now, so if I need, for instance, if I said 150 degrees, you could say, well, Mr. Davies, that's a 5 pi 6 radians. Or if I said, okay, I've got a 4 pi thirds radian, you said, Mr. Davies, that's easy. The angle is 240 degrees. Okay, that's easy, right? But if it's not on the unit circle, it still can be a radian. It just has to have a formula, okay? So the formula is right up here, degrees to radians. I'm going to write it slightly different, okay? So degrees to radians. So we're going to go and take a radian, and we want to make it into, so degrees, we're going to have a degree, we're going to change it to a radian. So we're going to write the radian is equal to pi over 180 times your degree. Okay, I want you to write that down, okay? That's our formula for changing a degree into a radian, okay? And we'll do an example here in a little bit, okay? Now the same thing's true as if you happen to have a radian measure and you want to change from radians to degrees. Yeah, Cody?
Isn't pi divided by 180 going to stay consistent the whole time?
Yes.
You have to write it as pi over 180.
Let me do an example in a little bit and you'll see it, okay? Okay. Now, if you want to go from a radian to a degree, then our degree would equal, you ready? I want you to write this down, 180 over pi times your radian, okay? Write that down. So that's our formula from converting some radian into a degree. So we know that if we look at our circle, they're there, right? You just go boom, 120, 2 pi thirds. But if it's not on the circle, we have to have a way to go ahead and get the other angle. So we just use our formula, okay? So as an example, if I take a look at an example, let's do an example down here. I said 50 degrees, right? So if I have 50 degrees, that should be some radian. I know it's around here somewhere, right? It's around here somewhere, but what's the radian, okay? So 50 degrees is right around here somewhere. So let's use our formula. So we're going to use this formula here. We're going to simply go, the radian is equal to pi over 180 times 50. Now I want to change this to a reduced fraction, okay? So it's the same thing, or it's the same thing as 50 over 180 pi, okay? Let's reduce that, right? Let's reduce that. Or it's the same thing as 5/18 pi. 50 degrees and 5/18 pi are the same angle. One is in degrees, one's in radians, okay? Now we can do the other way, but I'll wait and flip the book and we'll do the other way, okay? So right now let's go ahead and turn the page. You guys ready to turn the page? Okay, easy so far? Okay, turn the page. Now, protractor, right? So question number 1 says, all I want you to do is draw an angle in standard position. Now I know that this is 0 degrees. 260's got to be around here somewhere, right? Think about it. 180, 270, so 260 is around here somewhere. You guys agree with that? So if I use my protractor, and this is why I always buy the round ones, 260 is about there. Okay, watch. 10, 20, 30, 40, 50, 80, 90, 180, boom, 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 all the way to 260 is about there. So make a mark at 260 degrees, and I'm just going to draw in my angle. And there is, boom, draw my angle like that. There's my 260 degrees. Okay, easy? You guys agree? Now, negative 750, all right? So first of all, there's 360 degrees in a circle. If it's negative, we're going to go backwards. Now watch. If I start at 0, everybody watching, all eyes up here. Everybody, all eyes up here. Zeke, you with me? Watch. Watch. All eyes up here. Watch. I'm going to go backwards because of the negative. 1 revolution is 360, right? Another revolution is another 360. So I get 750. If I keep going, negative 750. If I add 360, well, hold on. 750 plus, oops, hold on, clear. Give me just a second. Negative 750 plus 360. I get an answer of negative 390. And then I go another 360. I'm at negative 30 degrees. Right? So this angle would go 360, right? But I got to go another 360. You with me? Another 360. Does that make sense? And then I'm going to go negative 30 more, and here's the angle I want. So negative 750 went 1, 2 revolutions back, and then an extra 30. Does that make sense how I did that? Okay, good. Now, let's go look at number 3. So if I look at number 3, it says that there should be one positive and another negative angles that are the same angle. Okay, now think about this. Okay, my tire. Okay, I've got a nail my tire right here at 60 degrees, right? I can roll my tire all the way forward 360 degrees, and the nail's in the same spot, right? Or I could take my tire, I got a nail right here, I can roll my tire backwards 360 degrees, same spot, okay? So that's all we're asking, is if we take 55 degrees, another way would be 55 plus 360 would be roll it forward, right? So if I go 55 plus 360, I get an answer of, whoops, hold on, 55 plus 360, I get an answer of 415. Okay, these are in the same position. These two angles are in the same position. This one just said a roll the tire forward 1. Okay, I could also go backwards. I can also go 55 minus 360, roll the tire backwards, right? So 55 minus 360, and I get an answer of negative 305. Okay? All 3 of these angles are in the same position, right? One has been rolled forward a full circle. The other's been rolled backwards a full circle. But they're all in the same position, okay? All right, so far so good. Okay, almost done. 7. Convert degrees to radians, okay? I've got a formula. I do, I've got a formula. Let's see, radian is equal to, I think it was pi over 180 times my degree, right? That's my formula we have from the front page, right? That's the formula I got from the front page, right? So I wrote that back down again. I'm going to highlight that formula so I don't forget it. So if I want to change 54 degrees into a radian, I'm just going to use my formula, okay? So I'm going to go radian is equal to pi over 180 times 54, okay? I'm just plugging 54 into it. Now I want my answer as a reduced fraction. So let me rewrite this.
Can you move it down?
Yeah, sorry, Katie. So I plugged my 54 right in for the degree. It's that easy. Just put the 54 in there. So I want to reduce fraction. Let me rewrite this as 54 over 180 pi. Now your calculator will reduce. Watch. You don't have to worry about reducing fractions if you just listen to how you do it. So my calculator will reduce fractions. I'm going to go and I'm going to push 54 divided by 180. Okay, see that? And I'm going to go into my math button, and there's a fraction. See my fraction button? Boom. 3/10. So 54 over 180 reduces to 3/10. So my answer is going to be 3/10 pi. Okay? 54 degrees and 3/10 pi are the same angle. They are. 54 degrees and 3/10 pi are the same angle. One's in degrees, one's in radians. Easy? Okay, now 16 is the same, number 9 is the same type of problem, except we're going to use the other formula. What's the other formula? Well, if we're going to change it into degree, we're going to use the formula where it's 180 over pi times our radian. So Cody, when you said aren't pi and 180 always go together, you're totally right. Always. Okay. So now I should be able to change 16/15 pi into a degree. It's easy. I know it's got to be more than 180. I'm sure of that. So let's use my formula. So I'm going to go, okay, degree is equal to 180 over pi times 16 pi 15ths. Okay? There you go. Sorry, my bad. Okay, so I'm using my formula here. I want to put it right there. Thanks, Cody. I need you to see that. Thank you. So I'm using this formula. Okay, all I did is I put the radian in for the r. Okay, now I'm going to simplify it. Well, first thing I noticed is I can cancel the pi's. Pi cancels pi's, right? And then I'm going to take my calculator. I'm going to go 180 times 16 divided by 15. Just use your calculator. Okay, I can do that. Heck yeah. I'm going to go, okay, 180 times 16 divided by 15 and 192. So, 192 degree angle. So, 16 pi 15ths radians is the same as a 192 degree angle. Okay? So, before I turn this recording off, radians are angles, right? Radians are angles. Okay?